Hi everyone, let's continue on question 18 in sample exam 3 in Chem 11. This is another electron configuration question specifically on transition metals. The question starts by asking us to write the complete electron configuration of manganese, and it's saying no noble gas shortcut, so we have to just write out the whole thing. And you remember that there is 3 different rules you need to keep in mind when you're writing electron configuration. So the first one is the Aufbau Principle, which is just that the electrons have to be filled in a certain sequence of orbitals, starting from the lowest energy orbitals all the way to the highest one. So we start with 1s2, s2p, etc. And then the second one is Pauli's exclusion principle. It means that you can't have more than 2 electrons per orbital. Okay, so maximum 2 electron. And third one is Hund's rule, the fact that if you have degenerate orbitals with the same energy, for example like a p orbital or a d orbital or an f orbital, that you fill them up one at a time and you don't pair them up first. So doing it this way would be wrong. Okay, all right, so let's take a look at manganese. If you look up the periodic table, manganese has 25 electrons. So let's start our configuration. So we'll have 1s2, 2s2, and then after 2s we have 2p, so that has a total of 6 electrons. And then 3s, that has 2, 3p has 6, and remember that with the sequence, the energy levels is such that the 4s orbital is actually lower in energy when it's empty compared to the 3d orbital, so we would do 4s first here, and that would have 2 electrons at the most. And so at this point we have 20 electrons, then we go to our 3d, and so that one would have 5 electrons. Okay. Now, so just to show this in the box diagram version, because that will be useful to help answer the rest of this question. This is 3p, this is 4s, then we have 3d, 5, which should look like that due to Hund's rule. Right? Now the next question says write the complete electron configuration of manganese 2+. So here's where you want to be careful with the transition metal ions. Remember that even though when we fill this in, our 4s comes before our 3d, but once you have them filled, the 4s is in the outermost shell, right? So if you think about the nucleus, first level, second level, third level, and then you have now fourth level, which is close to the third level, but still further away than the nucleus compared to the third level. So if you have 4s electrons, then those have to be removed first before you remove the 3d electrons. So the configuration for manganese 2+ then, which is 2 electrons removed, would look like this. 1, 2, 3, 4, and then here's the 2p electrons, 3s, 3p, those all don't change, but then now your 4s is gone. You remove 2 of those electrons because it's 2+. So then what's left is 1, 2, 3, 4, 5. So 1s, 2s, 2p, 3s, 3p, 3d. 5. Okay, that's your manganese 2. The last question asks about paramagnetism, and it says which one is paramagnetic, manganese or manganese 2+? Well, paramagnetism has to do with the ability to form permanent magnet with an element or an ion, and that's due to the presence of unpaired electrons. So if you have unpaired electrons, you can be made into a permanent magnet. So both of them, if you look at the configuration, have single electrons, so then both are paramagnetic. And so that's the answer to all the questions.